Hey guys, how are you? Uh, One second, guys. I have huge problems. Sorry, no. Thank you for asking. Oh, I'm good. I'm good. Okay. Last week's homework, I saw Yojit's comment that you were not able to open the challenge. You want to show us Yojit quick?
I couldn't open the challenge on my iPad when I was trying to open it. It said server not found.
Yeah, Ma, were you able to open it in the laptop or anything?
I didn't try on laptop because I only use iPad.
Okay, do you want to share the screen and show?
But it's on the iPad. I can't do it on the laptop because I don't have it signed into anything and my account's not on this laptop.
Doesn't. Oh, now you've logged in from an iPad. Now you've logged in from a laptop.
No, because I don't know my account info for the laptop. I can't log into the laptop because I have a different.
Now what are you using, Yojit?
Right now I'm using a laptop for the Zoom,
Oh,
but for my homework I use my
okay,
iPad.
then I don't know how to help you. Okay. Others, you were able to open the challenge assignment.
Yes.
Subi, were you able to open?
Yeah.
Okay. Any questions from any of you? Any questions from any of you on that?
No.
Okay. One of you had Viba. Viba, I don't want just the answers, ma Viba. Does that make sense? Just the answers doesn't suffice. I think some of them again forgot. Let me see, guys. Give me a minute. Okay. Vibha, that was only my request, Vibha. So just add on work. Work you have attached separately, Vibha. Honestly, I did not see that.
Priya,
Yeah,
I had a question on the last one.
absolutely. We'll go over, ma'am. Because you're learning it for the first time, right? Definitely you need inputs. I understand. You had questions on the last one, how to go there. Let's see. 1 second, okay? Geometry Sunday. Okay. Had questions on the last one. Let me share my screen with you. Yep. You're able to see? You're able to see, ma?
Yeah. Yes.
Oh, what is your question, ma? Which one, ma?
Question 44.
Please tell me the assignment. Which is the assignment you're asking questions on?
The challenge one.
Okay. Mm-hmm.
I wasn't sure how to do it. Just how to divide the figures into different figures.
Not at all a problem. 44, huh? 42.
Yeah. 44.
Okay. Okay. Any thoughts? Any thoughts for this? Any thoughts, guys? Whoever solved can say, right? Srishti, did you do this problem?
No, I didn't get all the way to that. But I think actually, hold on, let me check.
Hmm.
So I think for area, you have to find all the coordinates of each like corner, and then you can like make the lines like you can and letter them like A, B, C, D, and then like find the like the
Uh-huh.
you have
Find
to
the distance. Uh-huh.
find the distance of each and then multiply them all together.
Mm. Mm-hmm. In this figure, that's going to be difficult. I like the idea, but then in this figure, see, even if you split it, right, it becomes a quadrilateral, not even a trapezoid. So you don't know how to find the area of the quadrilateral, right? What do you think, Ashrita? Mitransh, what do you think? What do you guys think? Mm-hmm. Even if you split like that, right, it's not going to become a triangle. So there is a messy problem. This is, hey, Ashrita, you muted him, huh?
I was thinking that we could split it like here and then here.
How do you know that this is parallel to this?
I don't know for sure, but we can like measure the distance.
To show that they are parallel, you have to find their slope, right, ma?
Yeah.
So that, okay. So that's a little tricky again. Okay, good thought. But then if they're not parallel, what will you do?
I don't know.
There is a problem.
What if we find the area of the outside rectangle and then find the area of the smaller and not shaded triangles
Very
and then
nice.
subtract it?
Very nice, Yujit. So area of the outside. See, my only thing about this problem is when you look at it, right? Whatever you need to subtract are all nice shapes. You see? See, if you find the area of the big rectangle, and then these are all triangles, you see? So it's easy to subtract the areas of this. Does that make sense?
Yes.
Okay, see, it's just that, see, all the while we were only finding areas like splitting this into composite figures, we were splitting. But here there is a problem where you can think differently, meaning you have a big rectangle, finding the area of the triangles are so easy in here. See, 1, 2, 3, 4, 5 triangles you're going to subtract, that's all. Finding the area of these triangles are so easy. Why? Because these are all right triangles. You see, this one may not be. You can take this as two right triangles. You don't have to. You can take this as base, this as your height for the entire triangle. Make sense?
Yeah.
Okay. Any other questions? But good, very good question. Who asked this? Vibha, right? Who asked this?
Maybe.
Very nice one, Subi. Then what else? Any other questions? Any other questions, guys? No, yes?
No.
Okay. But please do the challenging assignment as and when you find time, okay? I have not set a particular timeline where you need to complete it, okay? I want to go to the next topic, but okay, let's see this one. How about this? What type of a quadrilateral is this? This is a good question for review. Okay, whatever we have learned, right? I need to review that definitely. So, how about this? I have a quadrilateral I have a quadrilateral with vertices QRSP. Can you please tell me, you do your own groundwork, okay? What type of a quadrilateral is this? What type of a quadrilateral is this? You're going to find, guys. You have to note down the points. Q2, 3. Note down the points. You have to note down the points. Okay, there are so many ways you can identify what type of quadrilateral it is. Think of properties of square. Square means sides are distance between the sides, right? Distance between the endpoints, right? They're all equal, and the slope should be negative reciprocals if they are perpendicular. Subi, can you tell me the distance between QRST?
I graph the points.
Subi, just give me some slope and some. And okay, let me also give you one more. Can you determine the length of the length LNGTH of the two diagonals? That will help me understand whether you have understood. Correct. Ma, please don't change radicals to decimals. Okay, you're not required to use calculators yet. You have to answer in radicals. That square root of 29 seems incorrect, Srishti. Correct, but your conclusion is correct. Okay, but each side is square root of 29. You're saying, Srishti, that doesn't. Oh, length of the diagonals. Yeah, but length of the diagonals is not square root of 29, ma. Can you check?
Yeah, it was my bad.
Yeah, no problem. See, at the end, we need to fix, that's all. Two by 5, then other slope is not. Did you get it, guys? Ma, I'll check the answers, ma. Please send. Oh yeah, Ashruta. Correct, ma.
Wait, no, but it has.
Nabiha, okay. See, everybody is getting square root of 29. Why I don't know. Ashruta, you're correct, Ashruta. Vibha, that's correct. Nabiha and Srishti, somewhere both of you are getting 29. So something is not clear.
No,
Let's
I changed it. I changed
change it, Amma. I did not see. Sorry, ma. I did not see. Wait. Uh, 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 oh my god, 2 by 5 is 0.458. Is correct. Slope is correct. Subi correct. Subi correct. Length of the diagonals, did you change, Srishti? I did not see. Yeah, you got it correct.
Oh, but it's.
But one another person got square root of 29. Who got it? Minus 5 by 2. Check. Nabiha also got square root of 29. I don't know, guys, what is the problem. I'm going to do it. I'm going to do it on the board. Looks like there are some of you are getting square root of 10. I don't know why. Okay. 2 comma 3. See, guys, I'm going to do it on the board. I'm going to do it on the board. 2 comma 3 minus 3 comma 1. R is minus 3 comma 1. Is it recording? The people who ask for recording. 1 minute, guys. Yes. Okay. And the next one is minus 1 comma minus 4. T is 4 comma minus 2. 4 comma minus 2. So here, guys, how do you prove what quadrilateral it is? The best way is find this. I would find the slope of RQ. Slowly I will find, but the slope of RQ. RQ slope is C. Y2 minus Y1. The ending is Q, right? So I'll start from there. 3 minus 1 divided by 2 minus minus 3. Right? 2 subtract minus 3. So that being the case, 2 by 5. Then RQ slope I found out. Now ST slope I'll find out. ST slope is the opposite side. Again, it ends with a T. So I'll start with minus 2 minus minus 4 divided by 4 minus minus 1. So this is 2 by 5. Again, they are equal. So if they are equal, I can conclude that since the slopes are equal, they are parallel. Now QT slope is what? QT means ends with a T, right? So minus 2 minus 3 divided by 4 minus 2 minus 5 by 2. Okay. So QT slope, similarly RS slope I'll find out. It's a big problem. Okay. RS slope I'll find out. How I'll find out? S, it ends with the S, right? So that why I'll start first. Minus 4. So to avoid confusion, I'm saying. Okay. Then change in X is again start from the same point. Minus minus 3. So that will be minus 5 by 2. So these two slopes are equal. So I can conclude that these two are parallel. Opposite sides are parallel. And yet another important property here you're seeing. See, this slopes of ST and QT are negative reciprocals. You negate it and flip it. So since they are negative reciprocals, I can say the lines are perpendicular. ST and QT are perpendicular. ST and QT are perpendicular. So all four, there are 4 90-degree, the perpendicular angles, right? So that tells that this quadrilateral is a square. And the length of the diagonals, let me find one length, QS. Length of the diagonal, how do you find the distance, QS? You see, it is just Pythagorean theorem, right? You all know 3. So you will find the square root of the change in y, 7 square, and the change in x, 3 square. You will add them both, 49 plus 9. So that will be 58. Nabiha, was that clear?
Yeah, I understood what I did wrong.
Okay. Mitranch, I didn't get an answer from you. Are you understanding or how?
I understand.
Okay. So be 58, Amma.
I know I did that wrong. I meant to put 58, but
Okay, no, see, as long as you understand, I'm happy. Okay, we'll move on. You know what? Now I want to stop share. I want to go to the next topic, but give me 1 minute, guys. I want to go to biconditionals and stuff. Let's see. It's an altogether different topic, so that will be a little off for you. Meaning, it's all based on logic. I would like to complete that and go to proofs before we finish summer, but let me quickly check something. Okay, so we did. Okay, we did distance, midpoint, all that stuff. Any type of problem you'll do. So perimeter, identifying the type of quadrilaterals you'll do. That is good. Oh, relationship in triangles. Yeah, I can do that. Oh, okay. Yeah, meaning before I move on to biconditional, see, this is something I missed in the sense I have to do this before going on to the next. Okay, that's okay. Let's do this one. I don't want to skip. Okay, then parallel perpendicular lines I will cover, then I'll go to conditionals. Okay, that's fine. No problem. How about this? Okay. We are going to study the different properties of triangles. Okay. Okay, let's go ahead. Let me share screen. Different line segments within a triangle. We are going to learn about it in detail. Okay. Segments in a triangle. I'm going as per Teague's order. Okay, that way we don't miss anything. Okay, if I don't go by Teague's order, I sometimes miss certain things. Segments in a triangle. When you think about it, let's say this is a triangle. What does it mean to say perpendicular? Let's say what is the perpendicular bisector of side BC? Do you know what is the perpendicular bisector? What is the perpendicular bisector?
It has to go exactly in between line segment BC, and it has to be vertical.
It will be vertical. Okay, vertical, but there is something else to it. It need not necessarily pass through the vertex. Okay, let me draw it in a different way so that you have that insight as well. Hold on. Let me draw it like this. Okay. Now, what is a perpendicular bisector? There can be one line from the opposite vertex coming down. Okay, this is one line. Okay, but is that the perpendicular bisector?
No,
Why?
it's because the bisector has to divide the line into two equal parts.
Exactly. The line BC is not divided into two equal parts by that line AE. So this line AE that is dropping from the opposite vertex, making a 90-degree angle with the base, right? That line segment, definitely it makes 90-degree angle. Okay, that is called the altitude or the height of the triangle. Height is the altitude. Altitude or the height of the triangle. Makes sense? So from this, see, if they want to confuse you with application problems, okay, they won't go to that level in geometry. But you know, if they can give you the line segment AE, they can give you the line segment BC. They can ask you, hey, prove that this is the altitude of the triangle. So what will you do? This is the application problem. You'll find the slope of AE, you'll find the slope of BC, make sure they are negative reciprocals. Does that make sense? Because altitude is the line segment that makes 90 degree with the base from the opposite vertex. However, we were discussing the perpendicular bisector, we left it halfway. What is that perpendicular bisector? Perpendicular bisector of this triangle of this side BC is this, where this distance is x and this distance is same x. You see what I mean? Am I making sense?
Yes.
Now, I just showed you one side, right? I just showed you one side. Let me, I don't know how to call this perpendicular bisector. Okay, let me call it as FB, FT. Of BC is FT. Okay, now I am just for simplicity's sake, first let's understand what are the different line segments in a triangle. Okay, perpendicular bisector, I told you it is the perpendicular to any side, okay, to any side, but it has to cut that side into two equal segments, bisector. Okay, altitude is the line that makes up 90-degree angle with the base and falls from the opposite vertex. Okay, there's something more. Okay, there's something more. Let's see this one. What is this? Or wait. This has to come here.
Slant height.
What is that line AO?
The slant height.
Nice thought about it. That's here it's not called the slant height. But what do you observe about the blue line? Again, do you see this is equal to this? But it now falls from the opposite vertex. It doesn't fall from somewhere unknown. Like a perpendicular bisector, it does not fall from somewhere, but it falls from the opposite vertex and bisects the opposite side. That is called the median. You see in a road, right, when you travel, the left side, right side, in between you have the median, right? So like that, but it has to fall from the opposite vertex. This is called the median. Did you get it? This one is the altitude. This one is the perpendicular bisector. The black one is the perpendicular bisector. Guys, now see, they will not ask you for definitions. The only problem with geometry is they will not ask you, hey, define the median. Questions won't be that straight. The problem is they will draw a triangle. They will draw something like this, AE, okay? And then DB, something like this. If they say, hey, prove that AE is the median to DB. What will you do? You will have to find what is this point, make sure, find the distance, this distance and this distance. Say that they are equal, find both and prove that they are equal. Then you prove that AE is the median to DB. Similarly, sometime they'll draw a triangle and draw a perpendicular line like this from the opposite vertex. Prove that AD is the altitude, means you have to prove first of all the slope is negative reciprocals. That only tells you that the lines are perpendicular. Okay, similarly, perpendicular bisector, how will you prove? That's a little, two things you need to prove. One is perpendicular you need to prove, and then you have to prove that this is also a bisector in the sense AE equal to EB. There are two things you need to prove for perpendicular bisector. Perpendicular is the slope of these two lines will be negative reciprocals. So you have to find the slope of this line, you have to find the slope of this line. They will be negative reciprocals. Second thing, for the bisector, what will you prove? AE is the midpoint of AB you need to prove. Did you get it?
Yes.
Okay. Can I go ahead with the next one? I don't want to confuse you, but it's good to learn all together. Okay. The next one, what I wanted to talk about was angle bisector. Angle bisector. which is the angle bisector. Let me draw the angle bisector. This is the angle bisector. What does it mean by the angle bisector? What do you think is angle bisector? You're okay? I'm sorry, guys. 1 second. Okay, so angle bisector of angle B is this angle ABM. ABM. Angle bisector of ABC. Angle bisector of angle B, or I can say angle bisector of angle ABC. Both are one and the same. You can use either one letter to indicate an angle, or you can use three letters in which the middle letter indicates the angle. So angle bisector of ABC is the line BM. Okay, but how do you indicate it? How do you know that? ABM here, ABM angle is congruent. I am more geometry person now. Is congruent to MBC. M, see this angle, MBC. This angle is equal to this angle. Then BM becomes the angle bisector of ABC. Any questions? There are three ways. One another thing. See, the angle B, right? I told you, right? You can call that as angle B, or you can call that as ABC, or you can call it as CBA. The center should be B, that's all. Any questions? When you point to a line segment, you can use only two capital letters. But when you point to an angle, it has to use one capital letter or three capital letters. Because see guys, last year and all I saw in geometry, after covering half of geometry, people start saying AC as an angle. I don't understand. You see, AC should be a line segment. Okay. So when you indicate an angle, it should either use a single letter or three letters. Three letters can be clockwise or anti-clockwise, but the middle letter should indicate the angle that you are referring to. Any questions? One second, guys. Let me make sure I have everything in place. Did I talk about everything? Altitude, median. Yeah, there is one more. Okay, the last one. Okay, I'll not overload you further to this. Shall we cover the last one? Mid segment. Mid segment. Mid segment means, hey, I will go ahead and plot the midpoint of two sides of a triangle. I will go ahead and plot the midpoints of two sides of a triangle. Okay? Join them. Join them. I will plot the midpoints, the line joining the midpoints of two sides of a triangle. Any questions? I do this triangle. This is a triangle.
Does it have to be straight?
It has to be. It has to be straight. Yes, it's a line segment, right? Okay, this is just theory. But when you want to prove it, it all requires application of whatever we have learned. Okay, now I want to discuss a little more. Let me discuss that in here in the same page itself because these are all related. Can I go ahead? You know what? I want to use this side. Midpoints of two sides. Okay, can I go ahead?
Yes.
Okay, now we discussed so many different line segments within a triangle, correct? How about this? Let's say, first let's take the perpendicular bisector. The perpendicular bisector. I want to take the perpendicular bisector. It can be anywhere, right? It doesn't meaning a perpendicular bisector can be. It need not join the other vertex. Now again, I am drawing the perpendicular bisector of this side. Okay. Again, I am drawing the perpendicular bisector of the third side. What did I do now? We just described the perpendicular bisector. What a perpendicular bisector is we learned. What a mid segment we learned. What is an altitude we learned. What is an angle bisector we learned. What is a median we learned. Now we took up a triangle. We are only going to concentrate on the perpendicular bisector. Okay. We are only going to concentrate on the perpendicular bisector. The same color let me use so that you can easily identify. If I draw the perpendicular bisector for the same triangle for all the three sides, the perpendicular bisectors will meet at a point, correct? Am I making sense? That point is called the circumcenter. That point is called the circumcenter. Why? With that point as center, I will always be able to draw a circle with the radius of that. The perpendicular bisectors meet at a point. That point is called circumcenter. If you want to be a more geometric person, I will really refer to point of concurrency. Circumcenter is the point of concurrency of the perpendicular bisectors. Perpendicular bisectors of the three sides of a triangle. It's a lot of theory. Now the same thing can happen with all the other segments, right? Why it's called a circumcenter for a perpendicular bisector? Because with that point as center, I will be able to clearly draw a circle around the triangle in such a way that the vertices of the triangle fall on the circle. So, the circle that surrounds the triangle will be called as the circumcircle. That's why the point of concurrency is called the circumcenter, because that point will be the center of the circle that I draw. Okay, to just summarize, right, what you really need to understand. You need to understand what is a perpendicular bisector for the side of a triangle. And then when you draw the perpendicular bisector for each of the sides of the triangle, right, then I would refer to that as the circumcenter. Any questions? For now, that is enough. Okay, we will redo this. Ramya Rajagopalanna. I think she's little early. Can I move on, guys? Can I move on?
Yes.
Okay. Now, let's consider perpendicular bisector we did. Can we do angle bisector? Angle bisector. We will redo this, okay? See, from your end, you know what you can do if you're really, if you all really have time, right? During summer, okay? In a geometry class, I usually don't ask kids to do this. But if you want to learn more, you know what you can do? Get a compass, get a scale, a ruler, and then a pencil. With that, try to draw an acute triangle. Okay. When you draw the acute triangle, then you don't know how to draw the perpendicular bisectors, I know. Okay. For you to draw the perpendicular bisectors, I have to teach how to draw the perpendicular bisector or Google it out. Draw the perpendicular bisector, see where the three bisectors of the triangle are meeting if it is an acute triangle. If it is an obtuse triangle, see where the perpendicular bisectors are meeting. You will be amazed to learn so many things. You figure out and learn. For a right triangle, draw perpendicular bisector for all the three sides. See where it is meeting. So you will be amazed to learn a couple of things if you do this. But it does require time. It's not that easy. Okay, so you are going to draw an acute triangle, you are going to draw an obtuse triangle, you are going to draw a right triangle. In all the three, for all the three sides, you will draw the perpendicular bisector. When you draw the, if you don't know how to draw the perpendicular bisector, don't worry at all, ping me, I can send you the steps how to draw the perpendicular bisector because I have not covered that yet, I know, in constructions. So you can see the point of concurrency of the perpendicular bisector in an acute triangle, obtuse triangle and a right triangle. So that's fun. Okay. But that is if in case you are interested and want to go outside and learn more. Okay. Now let's come to angle bisector. What is this point of, let's say, let me call this angle A, B, C. Angle bisector means it's going to bisect the angles. That's easy for me to draw. Angle, you don't know how to draw the angle bisector using compass, ruler and stuff. You need to Google it out, okay? Now, for the angle bisector, what is the point of concurrency of angle bisector? Of angle bisector. Here, that point of concurrency of the angle bisector is called in center. Why? Why it is called in center? Because with this point as center, you will be able to draw a circle that is whose see the points of the circle, the circle touches each side of the triangle at exactly one point. See here, point of concurrency of the perpendicular bisector, you can draw a circle around. That circle is called circumcircle. Now here, since it is inside, see here the circle is, in this case, circle is circumscribed. If you have a circle inside that touches the triangle on all the three sides at one point, then it is called the incircle. It is inscribed. The circle is inscribed in the triangle. So the point of concurrency of the angle bisectors is called in center. Okay. Now there are two more. Okay, mid segments we will not cover much. Okay, there are two more. What is the point of concurrency of the altitudes? I'm matching the colors, guys. What is the point of concurrency of the altitudes? What is the point of concurrency of altitudes? Point of concurrency of all of the three altitudes of a triangle is called orthocenter. Orthocenter. Okay, the last one. What did I leave? A median. I'll do that in here. Point of concurrency of the medians is called the centroid. So if you come across these terms, you should not feel like, oh my God, I have not learnt it. So the only takeaway from this is, in a triangle, what is a mid-segment? What is a perpendicular bisector? What is a median? What is an altitude? And an angle bisector. What is mid-segment, perpendicular bisector, median, altitude, angle bisector? Those 5 points we covered first. Then, then what did we cover? Point of concurrency of perpendicular bisectors was the circumcenter. Point of concurrency of the angle bisector was the incenter, because inside you can draw a circle. Point of concurrency of the altitudes is called the orthocenter. Point of concurrency of the medians is called the centroid. Having said this, right, you don't have to confuse much. Okay, problems of the homework will be like little bit of, hey, prove this, prove that, okay? That's it, okay? So again, it will depend on your distance formula or the midpoint formula that you've already used, okay? Coming to this one, right, the point of concurrencies, right, for anything, for all these, right, that is a whole different topic. We'll cover it again in geometry after a while, okay? Point of concurrency of perpendicular bisector, point of concurrency of angle bisector, point of concurrency of altitude, point of concurrency of median. We will do a whole set of another a set of problems in each of these topics. Okay, but off late it's very abridged, very shortly they cover. I don't know why, but 2-3 years back and all we were covering a lot of problems on medians, centroid, orthos, and nowadays what I see in schools they cover very less. But let's see, we have started in June, right? I would like to cover all of these because these things really help you prepare for your standardized exams. Right. Okay. Can I move on or are you all confused? Yojit, how are you feeling, Yojit?
Good.
Okay.
A little confused, but good.
Good. Okay. You want me to review once more?
No, it's fine.
Okay. How about Srishti, Vibha, Mitransh? You want me to review once more or you're good?
I'm good.
Okay. Again and again we'll do because see the point of concurrency and all I'll do it again anyway. Okay. But only that I don't want you to come and ask me, Auntie, what is the median? Auntie, what is the angle base? That I don't want to come and ask you. You know itself you understand. See, it all comes from the name itself. Perpendicular, bisector, mid segment. Altitude is the height you already know. Median, you know the road median. Angle bisector tells that it bisects the angle of each vertex. Mid segment, there's no point of concurrence. That we are not going to cover. Can I move on? Okay. Now, okay. How about this? Okay. How about this? We'll do one problem on this one. Okay. Can you, okay. I'll ask you this, okay? The point BD. You need to know the point B, right? 1 minute, wait, guys. AC and BD. BD, you don't have the point, right? How will you verify? Oh, I see. Okay, okay. Can you tell me what line segment is BD? BD is what line segment? It can be what? It can be perpendicular bisector, it can be angle bisector, it can be altitude median. What line, what type of line segment is AD in this triangle? BD. I'm sorry, BD. Sorry, BD. What type of line segment is this BD? Coordinate points you have to mark by yourself. This is 2, 4, 6, 8, 10, 12, 14, 16. Coordinate points you are going to mark it by yourself. It's I can help you if need be. If you ask, I'll definitely do. Wow, Yojit, good job. Nabiha, good job. 1 minute more. Correct. Correct. But how did you prove it, guys? Everybody has said the answer is this. But then how did you know? Vibha, how did you prove? Ilima, Vibha, how did you conclude that that's this line segment?
Because it goes straight down from B to like it isn't the middle of AC. It's like a straight line down, so it's the altitude.
There is a way to prove, right? You cannot say just by looking or assuming, right? See, that's what meaning. Who really reasoned it out? Who really saw how was it the altitude? How can you prove that that's the altitude? Nabiha, what did you do? So basically, this is a 15, right? This is a 12, 13, 15 comma 13. Did you guys do this? What is this point? 16 comma 6.
Miss Priya, point B is 13 comma 15.
Oh, sorry, ma. Yeah, 13 comma 15. Then this is 16 comma 6 comma 16 comma 6. Correct. Now, what is C point? 22 comma. This you need to do. Then only you can prove. Yojit, did you do this?
I looked at the other segments and I figured out what they were. And mostly because it's either BE or BD, that could be altitude, and BE is going as the bisector, so it couldn't be that, and
Correct.
FE
But
would
by
be
looking,
Nixon.
but did you prove using the distance formula, the midpoint formula, or the
Okay.
slope? You have to prove using that, okay? Meaning, in geometry, just by seeing or looking, you cannot assume anything. So here, what is the slope? 8 minus 2 by 22 minus 4 for AC. Slope of AC is this. Slope of BD is 15 minus 6 divided by 13 minus 16. So this will be 6 by 18. That is 1 by 3. Slope of BD is what? 9 by 3. 9 by minus 3. So it's a minus 3. See, these two slopes are negative reciprocals, which means that AC and BD are perpendicular. So I can conclude that B starts from the opposite vertex. So BD is the altitude. This is how you need to prove. Any questions? Okay. Now, how do you prove that GE is the perpendicular bisector? So you have to plot out points GE, you have to plot out points AC, then GE slope will be negative reciprocal of AC, that is for perpendicular. Then what you need to prove? The distance AE is congruent to EC. If you prove this proves that this is the bisector. This proves that the lines are perpendicular. With this, you can say GE is the perpendicular bisector of AC. Any questions, guys? So everywhere you need to use distance formula, midpoint formula, everywhere you'll use to prove that one is the perpendicular bisector, one is the altitude. How will you prove? What else is in here? Let me see. Oh, for you to prove that this is the mid segment, right? You have to prove that E is the midpoint of AC and F is the midpoint of AB, right? And then the last one is, what else? This one. This one I don't know. I need to see, okay? Here I don't know if it's the median or the angle bisector. So first AE is equal to EC if you can prove, right? Then it becomes the median. Any questions? Okay. Mm. Yep, I will. Uh-huh. Okay, how about this? Have you studied, do you remember parallel and perpendicular lines? Meaning parallel and perpendicular lines. So this is from Algebra 1, guys. This is just a review, okay? Slope of parallel lines are equal. Slope of perpendicular lines are,
Negative reciprocals.
yeah. This one comes from your Algebra 1, are negative reciprocals. This one, I really want to give you homework directly on this. Let me see. Yeah, how about this? Maybe we'll cover this next week. We don't need to be in a rush as well. Okay, let's try whether we can understand. Based on your understanding, if you are okay, I'll give. Okay, now there is a line y equal to, let's see, okay, if you can understand, then I'll give you homework on this. Y will be equal to minus 3x plus 6. Okay, would you, okay, this line is goes like this or like this. As soon as you see this, what do you think? As soon as you see the
It
equation of
goes
the,
down.
it goes down because of the negative slope, my mx plus b, right? And its y-intercept is 6, you know. Okay, good. Now, determine the equation of the line parallel to the given line. That means what? Let me consider the equation of the line for which I need to determine the equation, right? Let me say my line, okay? My line for which I'm going to find the equation, right? What I can tell, my line is parallel to the given line. So, what is common between the two? Slope. So, my line slope is minus 3. I got it from here. Okay. Now, my line passes through, my line passes what point? Minus 3 comma minus 4. Here, would you be able to write the equation of my line? How will you write the equation of my line?
You plug the points.
X and Y.
Yep, there is a slope, there is a point. What is the form you'll get it?
Slope intercept form.
Not the slope intercept form, a
Point
point
slope.
slope form.
Point slope.
Point slope form. Intercept, you cannot use this because the two lines intercept will be different. Parallel lines, when you think about it, right? Intercepts might be different. Only the slopes are equal, but then you have another point. So you can use point slope form. How do you use? Minus 3 will be equal to minus 4 minus y divided by minus 3 minus x. You can write this out as multiply by a negative sign everywhere. If I multiply by a negative sign, it's so hard. 3 times minus 3 minus x will be equal to, I'm multiplying by minus 3, minus 1 everywhere. So, see this? So, the equation of my line is minus 9 minus 3x will be equal to 4 plus y plus 3x will be equal to minus 5. Or y is equal to minus 5 minus 3x. So the equation of my line is this one.
Miss Priya, wouldn't it be minus 13, not minus 5?
Did I make a mistake? I'm sorry if I made the mistake. Yeah, minus 13. Correct. Thank you, Ashruta. Here, right? Here, right, Amma?
Yes.
Okay. So let me rewrite it. Y will be equal to minus 13 minus 3x. See, the slopes are equal, but their intercepts are different. You see, here the intercept was 6. Here the intercept was 13. Guys, are you comfortable if I give you some homework on this one? How many of you are not comfortable? Please raise your hand using raise hand button. I just want to make sure. Please raise your hand using raise hand button if you're not comfortable doing these problems. Okay, okay. Hey guys, now is the time for you to give the homework. I'm asking, are you comfortable doing homework you like problems like these?
Yeah.
Okay, so I'm assuming everybody's comfortable. Mitranj, are you comfortable?
Yeah,
You know it already?
a little bit.
Okay, so I will assign, but will you come and ask me if you have questions?
Yes.
Okay, see, at the end of it, right, I want everybody to understand. If I know some of you have not completed Algebra 1, some of you have completed Algebra 1. If you are not, a person who has not completed Algebra 1, you're going to suffer with this. Okay, but let me know if you suffer. Then we will see, we will review it once more and then keep going. So this week's homework will be on those line segment triangles and then parallel perpendicular lines. Sometimes they may ask you, given the line, this line, Determine the equation of a line that's perpendicular to the given line. So what will you do in that case? You already know the slope of this line. But my line, the slope will be what? The negative reciprocal means 1 by 3 will be my slope of, if my line is perpendicular to the given line. Are you all on board? Okay. Then they will give a point. It's very easy for you to find out the equation of a line that has the slope and passes through a point. You're going to write that out. Let's try. I'll give homework on both. Let me know how you find. If there are people who did not understand, I'll review that nicely and then keep moving next class. Any questions? Okay, guys, I'll stop here. But please finish the challenging assignment for G2AB. Those benchmarks, you need to complete the challenging assignments first. Okay, guys. See you all next week. Have a nice week ahead. Enjoy your summer.
Bye, Miss Priya.
Bye, Miss Priya.
Thanks, Priya.
Bye, guys.